Every single morning, without fail, it rises. It warms your face. It grows your food. It makes life on this planet not just possible with us, but beautiful. You have trusted it your entire life, and it has been slowly killing you the whole time. Right now, at this very second, the star we call our sun is changing, quietly, steadily, irreversibly, and new research has revealed something that scientists are genuinely unsettled by. The timeline we thought we had, it is shorter than we believed, not by thousands of years, not even by hundreds of thousands, by hundreds of millions. The question is no longer if the sun will end life on Earth. Scientists settled that long ago. The question, the one that is keeping researchers awake, is when. And the answer they keep arriving at is the same chilling word: soon. I'm Richard. And you're watching EW Universe. Join me today as we explore everything we now know about our sun's darkening future, including a discovery so recent, so unexpected, that it rewrote the deadline entirely. As always, let's start with the basics: what the sun actually is. The sun is not permanent. I know that feels strange to say. It has been there every day of every human life, every generation, every civilization. It predates us by 4.6 billion years. It feels, in every emotional sense, eternal. It is not. The sun is a star. Specifically, it is what scientists call a main sequence star, meaning it is currently in the most stable phase of its existence, converting hydrogen into helium through nuclear fusion deep in its core. But here is what most people do not realize. Every time the sun performs that fusion, every time it converts hydrogen to helium, the core gets slightly denser, slightly hotter, slightly faster. And so, with each passing million years, the sun gets a little brighter. Not dramatically, not visibly, about 1% brighter every 110 million years. Most that sounds harmless, doesn't it? But here is the thing about slow processes. They are still processes, and they still arrive. The brightening that will end everything. When the sun was born, 4.6 billion years ago, it shone at only 70% of its current brightness. So dim, in fact, that Earth should have been completely frozen. A solid ball of ice. Scientists call this the faint young sun paradox. And the fact that life began here anyway is one of the greatest mysteries in Earth's history. But now we are on the other side of that equation, because the sun today is already 30% brighter than it was at birth. And in approximately 1 billion years from now, it will be 10% brighter still. That doesn't sound catastrophic, does it? 10%. But here is what 10% more solar energy actually does to a planet like ours. It pushes Earth past what scientists call the inner edge of the habitable zone, the boundary beyond which liquid water on the surface can no longer exist. When that boundary passes Earth, the oceans start to evaporate. Not all at once. Not in a single catastrophic flood of steam, slowly. But water vapor is a greenhouse gas, so as more water evaporates, temperatures rise. As temperatures rise, more water evaporates. A feedback loop with no off switch. The water climbs into the stratosphere, where ultraviolet radiation splits it apart. Hydrogen escapes into space, permanently, and the oceans simply stop existing. Scientists call this the runaway greenhouse effect. And according to the latest climate simulations, it begins in roughly 1 billion years. 1 billion years. That sounds like an eternity. But consider this: the entire history of complex animal life on Earth, on everything from the first fish to the last human, spans only 600 million years. We have less than 2 of those left. The discovery that changed the deadline. But here is where it gets complicated, and where the most recent science delivers a twist that even veteran astronomers did not see coming. In November 2024, researchers R.J. Graham, Itay Halavi, and Dorian Abbott published a study in the Planetary Science Journal titled "Substantial Extension of the Lifetime of the Terrestrial Biosphere." And what they found genuinely surprised people. For decades, the accepted model said Earth's complex life would die not from heat, but from starvation. Carbon dioxide starvation. Here's how it works. As the sun brightens, Earth warms. To compensate, the carbon cycle draws more CO2 out of the atmosphere. Rocks weather faster, carbon gets locked away, and CO2 levels drop. Past a certain threshold, around 150 parts per million, planet trees can no longer photosynthesize. They die. And this threshold, scientists believed, would be crossed in roughly 500 million years, 500 million years. That was the old deadline. But Graham and his team found a critical error in those models. The rate at which silicate rocks absorb CO2 when they weather is far less sensitive to temperature than previously assumed, meaning the carbon drawdown happens much more slowly, meaning the CO2 starvation scenario is pushed back by roughly 800 million years. So instead of complex life ending in 500 million years, the new estimate is 1.6 to 1.86 billion years, nearly double. You might expect that to be good news, And in one sense, it is. We have more time than we thought. But in another sense, it changes how Earth dies. Because if CO2 starvation no longer kills us first, oh, then what does? The heat does. Surface temperatures climbing past 65 degrees Celsius, the last plants cooking alive, the oceans boiling. It is not a quiet death by depletion, it is an oven. The oxygen clock. Nobody told you about. But there is another deadline inside that deadline, one that was quietly established in 2021, and that most people have never heard of. Kazumi Ozaki at Toho University and Christopher Reinhard at Georgia Tech modeled the future of Earth's oxygenated atmosphere and published their findings in Nature Geoscience. What they found was disturbing. Earth's oxygen-rich atmosphere has a mean remaining lifespan of just 1.08 billion years. And when deoxygenation comes, it will not be gradual. It will be abrupt. Oxygen levels collapse to near zero in approximately 10,000 years. Methane surges to 10,000 times current concentrations. The sky chemistry of Earth reverts to something resembling the Archean era, before complex life existed. Think about that. The entire oxygenated world. So if the world that made animals, forests, and humans possible represents only about 20 to 30% of Earth's entire lifespan, we are not at the beginning of Earth's story. We are somewhere between the middle and the final act. The sun is already surprising us. Now, you might be thinking, all of this is billions of years away, comfortably distant. But here is what scientists did not predict. The sun is not waiting politely. Every 11 years, the sun cycles between a quiet phase and an active one. During solar maximum, sunspots multiply, solar flares erupt, and massive clouds of magnetized plasma called coronal mass ejections are hurled outward across the solar system. In 2019, NASA, NOAA, and the International Space Environment Service convened a panel to predict the upcoming solar cycle 25. Their conclusion was cautious, a moderate cycle. A peak sunspot number of 115, arriving around July 2025. They were wrong. Solar cycle 25 peaked in October 2024, a full year early, and not at 115, but at 161, 40% higher than forecast. Well, the year 2024 produced 54 X-class solar flares alone, a record since records began in 1996, nearly double the previous highest annual total, and then came May, the storm that shrank. Earth's shield. Between May 7th and 13th of 2024, a single sunspot region, 15 times wider than the entire Earth, unleashed 82 notable flares, including 9 of the most powerful class possible. Multiple coronal mass ejections slammed into Earth simultaneously. The resulting geomagnetic storm reached G5 level, extreme, the most powerful in 21 years. The aurora was visible in Florida, in Puerto Rico, in the Yucatan Peninsula of Mexico. Some historians believe it was the most dramatic aurora display in over 500 years. But behind the beauty was a warning. Japan's Arase satellite recorded Earth's plasmasphere, the protective bubble of charged particles surrounding our planet, shrinking to 1/5 of its normal size in just 9 hours. GPS signals drifted by up to 70 meters. Satellites began dropping altitude. Ochinto 12 Starlink satellites re-entered the atmosphere prematurely. A weather satellite went offline. And the agricultural sector alone suffered over $500 million in damages from disrupted GPS-guided farm equipment from a single storm that lasted a week. Now imagine a storm 10 times more powerful. The day we almost didn't survive. You may not know this, but we came within 9 days of civilizational catastrophe. On July 23, 2012, a coronal mass ejection of historic proportions tore through Earth's orbital path. It was Carrington class, the most powerful type of solar event ever recorded, named for English astronomer Richard Carrington, who first observed such a flare on September 1st, 1859. In 1859, the damage was telegraphs bursting into flames, operators receiving electric shocks through their equipment, aurora so bright that Rocky Mountain miners woke at 1 a.m. and began cooking breakfast, believing it was dawn. In 2012, the CME missed Earth by 9 days. If our planet had been slightly further along its orbit, the National Academy of Sciences estimated a Carrington-class storm today would cause over $2 trillion in damages. So Lloyd's of London updated that in 2025, projecting losses up to $9.1 trillion over 5 years of recovery. And the internet, researchers from UC Irvine found the undersea cables that carry global data are uniquely vulnerable to geomagnetically induced currents. Entire continents could go offline, not for hours, for months. Astrophysicist Pete Riley calculated there is roughly a 12% probability of a Carrington-level storm hitting Earth in any given decade, 1 in 8 every 10 years. What comes next? So where does all of this leave us? The picture that emerges from 2024 and 2025 research is of a star that operates on every timescale simultaneously. On the scale of centuries, there is a 12% chance per decade of a civilization-level solar storm, and superflares strike sun-like stars roughly every 100 years. On the scale of millions of years, the sun's magnetic field, shallower than we knew, drives solar activity in ways our models are only beginning to capture. On the scale of billions of years, Earth's biosphere has between 1 and 1.86 billion years remaining. Not from explosion, not from collapse, but from warmth. The same warmth that made life possible in the first place. In November 2025, researchers at UCL and the University of Warwick published data showing that when stars like ours age and expand into red giants, they devour their closest planets with startling efficiency. Across nearly 500,000 stars studied, the occurrence rate of close orbiting planets dropped threefold in the very first phase of stellar aging. Mercury will go, Venus will go, Earth is unlikely to survive either. And yet, even that is not the final chapter. When the sun eventually swells and its warmth reaches Saturn, Europa, one of Jupiter's icy moons may briefly thaw. For perhaps 200 million years, an ocean may flow where ice once was. The same star that ends life here might begin it somewhere else. I'm Richard, and you are watching EW Universe. That perhaps is the most extraordinary thing about our sun. Well, not that it will destroy us, but that even in its destruction, it cannot stop creating.